have to do with this. The step 0 that I always tell you to do, check if it's balanced. What can you tell? Is this equation balanced or we need to balance it?
It's balanced.
It is already balanced, okay? It is correct. It is already balanced, okay? So you have chlorine, you have 2 in one side, and you have 1 plus 1, you have 2 in the other side, okay? So yes, it is balanced. Carbon, you have 6 in this side, and the other side you also have 6. And hydrogen, you have 6 here, and you have 5 plus 1, you have 5 plus 1 makes 6. So yes, the equation is already balanced, but it's always good thing to check. Okay, so then it says, when 36.8 grams of benzene react with excess of chlorine, the actual yield is 38.8 grams of chlorobenzene. What is the percentage yield? So we need to organize the data. Okay? I'm going to work on the question first, and then I will organize the data. So they are giving me 36.8 grams of benzene. So I am relating benzene with the other data here. Okay? 38.8 grams of chlorobenzene. These are the two substances that I am relating here. Benzene against chlorobenzene. Okay. It says they are given 36.8 grams, okay, and according to what you obtain in the lab, it says the actual yield is 38.8 grams. This is what you obtain in the lab. Remember, in the lab is the actual yield. So they are asking me to find the percentage yield of chlorobenzene. So I always need to relate the data given with the data unknown. Okay, so it's asking me the percentage yield of chlorobenzene. Basically, this is what I need to find. And what we're going to be focused on. Okay, so we say, do we have the theoretical data? Do we have the theoretical data? No, we don't have it. Okay. Do we have the actual data? Do we have the actual yield?
Yes.
Yes, it is given there. 38.8 grams of chlorobenzene. And they are giving me the limited reactant. The problem tells me which one is the limited reactant, even though it's not specified in words. Okay? It says benzene reacts with excess of chlorine. Okay? So this means this is the excess reactant, and in the other case, benzene is going to be the limited reactant because we have two reactants. Okay? If one of them is the excess reactant, the remaining is going to be the limited reactant. So I'm gonna write right here that benzene is the limited reactant. So the theoretical yield is what you obtain from the limited reactant. So we say okay, we say solution. So we get, for the theoretical, what we do is, for the theoretical, what we do is we apply stoichiometry, okay? To know what kind of a stoichiometric process you need to use, you need to see the units. They are giving you grams, and they are also relating grams. Okay, so the stoichiometric process that you will do here is from grams to grams. Okay, a long process that I told you how to work with. So we say, we always begin with a given, and I always tell you, write your plan over there, write the path to follow. So when you have grams and you're looking for grams, the path is grams given to moles given to moles unknown, and then finally to grams unknown. That is your plan, okay? That's your plan. So begin with the grams given. The given is the limiting reactant benzene. So it says 36.8 grams of benzene, and I'm gonna work with this times. So from grams given to moles given, I need to use molar mass of my given. What is the molar mass of benzene? What is the molar mass of benzene? I'm gonna get it here. Okay. So C6H6, the molar mass is 6 times 12 plus 6 times 1. This gives me 78 grams per mole. So I'm gonna write the molar mass as a conversion factor. Okay, I'm gonna write the molar mass as a conversion factor. So the 78 grams should be in the bottom, so I can cancel it. And in the top, 1 mole of benzene. Here we can cancel, and we continue, okay? This step is already done. So now I need to work with moles given to moles unknown. So I need to use molar ratios. To use the molar ratios, I need to see the equation. What is the molar ratio between my two substances? What is my mole ratio between my substances? Guys, what are the two substances that I'm relating?
Benzene and chlorobenzene.
So you need to write the molar ratio. The molar ratio that relates the coefficients. And the coefficients, because they are invisible, you know there is invisible one in each side, okay? So it is invisible one for each, and in the end, you're gonna have 1 mole over 1 mole. And here you organize the data in a way that you can cancel the benzene. So benzene should be in the bottom. So you put 1 mole of benzene, and in the top you will write 1 mole of chlorobenzene. Okay, the molar ratio is 1 against 1. So you're going to put them two numbers, 1 against 1. So once you do the mole to mole conversion, it's missing moles unknown to grams unknown. So you need to use here the molar mass of the unknown substance. So your unknown substance is chlorobenzene. So you say, you're gonna write chlorobenzene in a way that you can cancel it. So you put 1 mole of chlorobenzene. And you calculate the molar mass. I will calculate the molar mass right here. So I say C6H5Cl. The molar mass is 6 times 12 plus 5 times 1 plus 1 times 35.45. How much do you get here? How much do you get here?
112.56.
112 point
45.
45 grams.
56 with decimals.
If you put the decimals, yes. I did it, so I'm going to write my answer, okay? Because I didn't put all the decimals. But both answers are correct, okay? Grams over moles of chlorobenzene. So that is the data that I'm going to use in the conversion factor. So 1 mole of chlorobenzene has a mass of 112.45 grams of the same substance. So how much do you get from there? Remember to cancel the units. How much do you get here?
53.005.
53.05, and you write the units, grams of chlorobenzene. Okay. So this answer that you get here, is what we know as the theoretical yield. Remember this. So this is the theoretical yield. It comes from the limiting reactant. Is this what you get in theory by doing all the process? Now, from the theoretical yield, now you can apply the percentage yield. Okay? So I'm going to write the formula for percentage yield. Percentage yield is equal to actual divided by the theoretical times 100. So the actual is given in the problem as, I'm going to show you the word problem again. It says the actual yield of chlorobenzene is 38.8. That means that in the lab, you were expecting to get 53 grams. But really, what happens? Well, life is what happens, okay? You didn't get what you expected. So 38.8 grams of chlorobenzene divided by the theoretical, that is what you just got, 53.05 grams of chlorobenzene times 100.